Atlas paid a visit to our little red neighbor, passing just 0.19 astronomical units, or about 28 million kilometers from Mars. This was a cosmic stroke of luck, offering a unique opportunity for the fleet of robots currently exploring the red planet to observe. NASA's Mars Reconnaissance Orbiter swiveled its HiRISE camera toward the visitor. Now, HiRISE is powerful enough to spot a coffee table on the Martian surface from its orbit of 200 to 400 kilometers above. If anything was going to be able to get a resolved picture of the nucleus, it was this camera. But the US government shutdown affected many of NASA's departments, meaning it took weeks for the pictures to be published. The long wait to get a hold of these images sparked conspiracy theories that NASA had seen something unusual, perhaps extraterrestrial in origin, and were withholding it from the public eye. The images finally released by NASA nearly 6 weeks later were underwhelming. They show a fuzzy, unresolved blob. Even from this distance, the nucleus was hidden deep within a shroud of gas and dust, measuring 1,500 kilometers across. Although we didn't get a beautiful, pristine photo of our interstellar visitor, at the very least, this non-detection may help scientists pinpoint how large 3I Atlas really is. But we already know from observations made by the Hubble Space Telescope that it is likely no more than 2.8 kilometers wide. But MRO wasn't alone. ESA were busy imaging 3I Atlas with Mars Express and the ExoMars orbiter, and NASA's MAVEN orbiter used this ultraviolet spectrograph to image the comet's hydrogen envelope.
ESA. I wish this comet well. I wish this comet that whatever they want, I hope that this comet is balance and harmony. That's what I hope. Whatever this comet is, whatever this 3I Atlas is, I'm gonna say that as long as it's balance and harmony, and it's truth and peace and freedom and equality, and then bring it on. If it's not, then yeah, I don't wish it well, because we have enough to deal with. So let's look at 3I Atlas.
Revealing a massive cloud of gas extending far beyond the visible coma. Perhaps most incredibly, the Perseverance rover, sitting in Jezero crater, fresh from discovering what might be evidence of life on Mars, pointed its mast cam skyward. In the resulting long exposure images, 3I Atlas appears as a faint, ghostly smudge drifting among the stars. These images may not look like much, but they are truly groundbreaking. This is the first time we have ever imaged an interstellar object from the surface of another world. And then, it was the moment we've all been waiting for, perihelion. As 3I Atlas emerged from behind the sun in November, panic spread through the astronomical community. Harvard astrophysicist and avid 3I Atlas commentator, Professor Avi Loeb, suggested that the comet had fragmented, that it had exploded into 16 pieces. It looked like our chance to observe this rare interstellar visitor might be over for good. His hypothesis was fueled by calculations suggesting the comet's mass loss was unsustainable. With the brightness surging so intensely, some models predicted the nucleus must have disintegrated to provide that much surface area for sublimation. However, new observations from the Lowell Observatory and the Virtual Telescope project have calmed these fears. Astronomer Zhang reported that the comet appears perfectly normal and healthy. There is no train of fragments, no chaotic debris cloud. The nucleus survived. The explosion was simply an intense period of activity, a natural fireworks show driven by the shedding of that outer crust. So, the comet is in one piece. But those who have been following the story of 3i Atlas over the last few months will not be surprised to find out why Avi Loeb was so concerned that it had fragmented. Over the last few months, Loeb had published a series of articles on Medium arguing that the comet's behavior exhibits anomalies consistent with extraterrestrial technology. Specifically, Loeb points to two features: a sunward jet appearing in images and what he describes as non-gravitational acceleration that keeps the object on a remarkably straight trajectory. Loeb argues that the mass loss required to produce such acceleration by natural outgassing would be immense, potentially enough to disintegrate the object. He suggests that if the gas cloud isn't massive enough to account for the thrust, we must consider artificial propulsion. As fun as this is to think about, and perhaps even to hope is true, in this case, unfortunately, standard cometary science offers robust natural explanations for these phenomena. First, the sunward jet. Normally we expect comets to have a tail, or trail of gas and dust expelled from the comet, pushed behind it by the solar wind. 3i Atlas, however, appears to have a second tail in the opposite direction, facing towards the sun instead of away from it. Images from the 2-meter twin telescope in Spain's Canary Islands, taken on the 2nd of August but first released in October, show this jet close up. This image, a composite of 159 exposures lasting 50 seconds each, shows 3i Atlas as a big black dot in the center of a white glow. But the break in this glowing ring shows a jet of material blasting off the comet in the direction of the sun. Now, while this might look like a thruster firing against the direction of motion, this sunward jet is a reasonably common feature in comets. As a comet approaches the sun, the side of the comet facing it will heat up faster. If there's a weak spot on the surface, sublimating gases can then shoot out of the comet towards the sun. The solar wind pushes this material back, creating a fan or spiral structure that, from Earth's perspective, can look like a forward-facing spike. So this is not an unusual thing to see. In fact, similar features were observed on Comet Halley, Neowise, and Comet 67P. Second, let's address the non-gravitational acceleration.
Kids, do you know what the point of luxury travel is?
Together